Last class we discussed the integrated rate law. Now we can see some problems based on these equations and half-life period. What is meant by half-life period of a chemical reaction? Half-life period means it is the time required to complete half of the reaction. That means it is the time required to reduce initial concentration to half of the initial concentration. That is half-life period. Half-life of a reaction is the time in which the concentration of a reactant is reduced one half of its initial concentration. It is represented as T half. Here we have two cases, zero order reactions and first order reaction. And what is the integrated rate law equation for zero order reaction? K is equal to concentration R0 minus R by T. Concentration of R0 initial concentration minus R, concentration of R, that is concentration at time T. When T changes to T half, that means T is T half, half-life period. When time is half-life period T half, concentration of R will be half of the initial concentration. That means half into concentration of R0, half of initial concentration. That means half into concentration of R0. Therefore, the rate constant at T half becomes K is equal to R0 minus half R0 by T half. R0 minus half R0, half R0. Half R0 by T half. Or T half is equal to R0 by 2K. T half is equal to R0 by 2K. It is the equation to find out half-life period of a zero order reaction. If you want to find out half-life period of a zero order reaction, should know rate constant. And from this equation you can see T half is proportional to initial concentration for zero order reaction. T half is proportional to initial concentration for zero order reaction. Now the case of first order reaction. In the case of first order reaction, as we mentioned, when T changes to T half, when T changes to T half, what happens? Initial concentration will be reduced to half of initial concentration. That means R will become concentration R0 divided by 2. So substitute the values. K is equal to 2.303 divided by T half log R0 divided by R0 by 2, not R by 2, R0 by 2. Here it is a mistake. R0 by 2. Or T half is equal to 2.303 by K log 2. And you know the value of log 2, 0.3010. So 2.303 into 0.3010 divided by K, that is equal to 0.693 by K. T half is equal to 0.693 by K. You can see T half is a constant. Here no initial concentration term in this equation. So we can say T half is independent of initial concentration in the case of first order reaction. So for zero order reaction, T half is proportional to initial concentration. But for first order reaction, T half is independent of initial concentration. Now see some, it is a special case if instead of concentration, if partial pressure is given, then how will you use this equation? A gaseous reaction is given, A gives B plus C. Reactant A changing to products B and C. The initial pressure, that means pressure at the beginning is P initial, atmosphere. That is the pressure of air law. But after some time, what happens? X amount of, or a small amount of A is converted to, a certain amount of A is converted to B and C. If there is B and C, that also will contribute to the total pressure of the mixture of gases, isn't it? So the pressure of A will reduce to Pi minus X, and if there is a reduction of X atmosphere in its partial pressure, that will be converted to B and C, or we can say partial pressure of B is X atmosphere and partial pressure of C is X atmosphere. Where Pi is the initial pressure at the time T is equal to 0, and partial pressure at time T is equal to Pi minus X plus X plus X, that is equal to Pi plus X, or we can say X is equal to P T minus Pi. That means partial pressure at time T minus initial partial pressure, where Pi is equal to Pi minus X equal to Pi minus Pt minus Pi, minus minus plus, so 2Pi minus Pt. That is the partial pressure of A. So initial concentration is proportional to partial pressure of A at the beginning, that is Pi, and final concentration is proportional to partial pressure of A after time T, that is Pa. So K is equal to 2.303 divided by T log Pi by Pa, but Pi is equal to 2 Pi by Pt. Therefore, K is equal to 2.303 divided by T log Pi by 2 Pi minus Pt. It's not very important, only those who are preparing for competitive examinations study it thoroughly. So just to follow it, it is very easy to understand. Just work out it in a paper, then it will be clear to you. Now read the question. The initial concentration of N25 in the following first order reaction. N2O5 gives 2NO2 plus half O2 was 1.24 into 10 raised to minus 2. That means concentration of A0 is equal to 1.24 into 10 raised to minus 2 mole per liter at 318 Kelvin. The concentration of N2O5 after 16 minutes was 0.20 into 10 raised to minus 2. That means concentration of reactant after time T is 0.20 into 10 raised to minus 2. Calculate the right constant of the reaction at 318 Kelvin. What is our equation? K is equal to 2.303 divided by T log concentration, initial concentration divided by concentration after time T. So write the equation first. K is equal to 2.303 divided by T log concentration of R0 divided by concentration of R. Do you write it? Now substitute the values. K is equal to 2.303 divided by, what is the time? What is the time? 60 minutes, that is given here. After 60 minutes, that means the time taken 60 minutes. So 2.303 divided by 60 into log initial concentration 1.24 into 10 raised to minus 2 divided by final concentration 0.20 into 10 raised to minus 2. Then you can find out the answer. You will get a rate constant in per minute, not in per second. You will get it in per minute because we are directly substituting time as 60 minutes. Is it clear? Try to find out the answer. Solve it yourself. Now the next question, for 5. A first order reaction has rate constant 1.15 into 10 raised to minus 3. K is given. K is equal to 1.15 into 10 raised to minus 3 per second. How long will 5 grams of this reactant take to reduce to 3 gram. Here what you have to find out? Time t. You have to find out time t. Concentration of R0 is equal to 5. That is the initial concentration. What is the concentration after time t? Concentration of R is equal to 3. So here what you have to find out? T. T is equal to, what is the equation? T is equal to 2.303 divided by K log concentration of R0 divided by concentration of R. Substitute the values. 2.303 divided by 1.15 into 10 raised to minus 3 into log 5 by 3. You will get time in seconds. Solve it and you will get time in seconds. I think it is clear to you. Now for 6, that is a simple question. Time required to decompose SO2Cl to half of its initial amount is 60 minutes. Means T half is equal to 60 minutes. Right, T half is equal to 60 minutes. What you have to find out? If the decomposition is a first order reaction, calculate the rate constant of the reaction. You have to find out K. What is the relationship between K and T half for first order reaction? K is equal to 0.693 divided by T half. So K is equal to 0.693 divided by 6T. You will get K in per minute. I think it is clear to you. Now we can see another problem. If you can solve it, I can say you got all the points related to this topic. Experimental data of decomposition of N2O5 in gas phase at 318 Kelvin are given below. Decomposition of N2O5, 2N2O5 gives 4NO2 plus O2. Time in second is given 0, 400, 800, 1200, and concentration into 10 raised to 2 mole per liter also given. So at the 0 concentration, 0 time, what is the concentration? 1.63 into 10 raised to 2 mole per liter. At the 400 second, 1.36 into 10 raised to minus 2, 10 raised to 2 mole per liter. In that way. First one, plot a concentration of N2O5 against T. Have to plot a graph in which you can take concentration of N2O5 in the y-axis and you can take time in the x-axis. So as the time proceeds, what happens? Concentration decreases. You'll get a curved graph. Find the half-life period of the reaction. And here, half-life period, it is very easy to find out. 1.63 to reduce 1.63, if it is reduced to half, what will be the concentration? 0.815, isn't it? 0.815, 0.815 nearly here. So in between 1200 and 1600. So you will get the value clearly from the graph. After plotting the graph, you will get the value. I will show the answer, but now you try to do it yourself. Draw a graph between log N2O5 and T. Log N2O5 in the y-axis and T in the x-axis. Then what will you get? Get a straight line graph. You will get a straight line graph with the slope is equal to minus K. Slope is equal to minus K. Now, what is the rate law? If you are getting a straight line graph, surely it will be first order reaction. Calculate the rate constant. If it is a first order reaction, you can find out the rate constant from the slope of the graph, isn't it? Calculate the half-life period from K and compare it with the 2. From K half-life period, T half is equal to 0.693 divided by K. You can see the solution here. Graphs are plotted. First one, plot of concentration against time. You are getting a curved graph. You can see it. Second, concentration of N2O5 1.63 into 10 raised to minus 2, initial concentration. So concentration at T half 1.63 into 10 raised to minus 2 divided by 2 equal to 0.815 into 10 raised to minus 2. And you locate this concentration here. Okay, you can see it here. And here the value is taken as 1440 seconds. So that will be the half-life period. Now third, plot of log N2O5 versus time. Log N2O5, that is plot against time, you are getting a straight line graph. And fourth one, as plot of log N2O5 versus time is a straight line, the reaction is a first order reaction, therefore rate law, rate is equal to K into concentration of N2O5. So if it is a first order reaction, slope of the line is equal to minus K. Slope of the line is equal to, since here log is logarithm to the base 10 is plotted against time, slope of the line is equal to minus K by 2.303. Minus K by 2.303. Slope, how will you find out the slope? Minus 1.80 is not 0. Nearly here. Minus 2.46. Here it is taken as minus 2.46. And this one is taken as minus 1.79. Near to 1.80. Minus 1.79. Minus 2.46 minus 1.79 divided by 3200 minus 0. So slope is equal to minus 0.67 divided by 3200. That is K by 2.303 is equal to, here there is a minus, here there is a minus, both cancel. 0.67 divided by 3200, or K is equal to 0.67 divided by 3200 into 2.303 equal to 4.82 into 10 raised to minus 4 mole per liter per second. 6. T half is equal to 0.693 by K. Substitute the value of K here and you will get 1438 seconds. Here 1440 seconds, almost equal. Okay, it is enough. All the problems, some of the important problems we discussed.